This video begins our lecture on normalization. We will cover operations that can occur against the database, anomalies that might arise from these operations, and functional dependencies before we get into normalization. So to begin, what are the operations that can happen against the database? The first one is the insert operation, where you add new rows or new records to a table. The second is an update operation where you change values inside of a column in a table. The third one is a delete operation, as you can see there. It removes rows or records from a table. So as you perform either of these operations, you can encounter anomalies. The first one is the insertion anomaly, which states that new rows create duplicate data or certain facts that cannot be recorded. So for example, if I were to insert a new customer with the customer ID of 9, with the name of Duncan's Furniture in Syracuse, New York, I couldn't just add this without attaching this customer to an order or to a product, etc. Otherwise, I'd be violating some of the constraints that would exist, since we would need like a product ID or an order ID, etc. So all of these facts must be recorded or I would have errors. And this is what we call an anomaly. The second type of anomaly is the update anomaly, which states that changing data in a row forces changes in other rows. So for example, looking at the address column, if I were to change the address of Value Furniture from Plano, Texas to Odessa, Texas, I would be forced to change this in multiple other rows because Value Furniture exists in other rows. So I'd have to change it in at least 2 other rows as demonstrated in this table. If I forgot to change one of these values, I would have an update anomaly. The third type of anomaly is the deletion anomaly, which basically states that deleted rows result in the loss of data needed for future rows. So for example, if I were to delete order ID 1006, I would lose all the customer information associated with this because I don't have this customer associated with any other orders. Additionally, I would lose the dining table and writer's desk because I don't have this information represented anywhere else. Entertainment Center would stay because I have Entertainment Center represented with order ID number 1007. So being forced to delete other values or lose other values is called a deletion anomaly. So this slide has a relation that is not very well normalized. So what I want you to do is identify all the anomalies that could occur, including an insertion anomaly, an update anomaly, and a deletion anomaly. So try this on your own, pause this video, and then come back to compare your answer. All right, welcome back. So as we look through this relation, we can see that if we were to insert a new ship, we'd automatically have to assign a captain to that ship. We'd automatically have to assign items to that ship and a shipment to that ship based on the way this relation is structured. Additionally, if we were to include a new captain, we'd have to include all the others as well. If we were to include a new item, we'd have to include a new shipment, a new ship, etc. An update anomaly would occur if I were to update a certain value that is repeated more than once. So for example, if I were to change the ship name Black Pearl to another name, I'd have to change it for the first 3 rows indicated here. Same with the destination or the origin or even the captain name. For a deletion anomaly, if I were to delete the shipment ID number 1, I would lose the golden medallions because they're not represented anywhere else in this table, assuming that this table is complete with all of our data.